Okay, we are asked to find the area of triangle EFG if it's an equilateral triangle and a square is inscribed in it as shown. Okay, the first thing that will make my solution very short is that there is a relationship connecting a square inscribed in a triangle. So if you have a square, a triangle of base E, and a height of H, the side of this square is related to the height and the base. So the side is always equal to the base times the height over the base plus the height. I'll prove it later. From here, x squared is now E squared H squared over E plus H all squared. That's the area of the square, and they gave us to be 12. The height of an equilateral triangle is always related to the base or the sides. Yes, if you look at it, if I join so that you can see, this is also the height. This is 60 degrees, and from here to here is half E. Yes, so you can easily see that the height is always E over 2 root 3. So that's another thing. The height of an equilateral triangle and the side are related. They are related. Height is always half of the side times root 3. So I'm going to use all this information to solve this. So they gave us the area of the square. So from this, you know that we are now given the area of the square to be 12. So 12 is equal to E H squared. But I told you that H is E over 2 root 3. So all squared. Do you get EH all squared? Though I expanded it here. H is this all squared over E plus E over 2 root 3 all squared. So continue. Okay, this is equal to this E times E squared all squared. So what I will do, I will move the square, this square to this side to be the square root of 12 to make it easy. So this is square root of 12, while this is now E squared root 3 over 2 divided by, this is 2E plus E root 3 over 2. So this is square root of that is 2 root 3. Why this is 2 gone, and we have E here, we have E. So we have E root 3. That's 1 E is gone. E is over 2 plus root 3. Do you get the logic? 2 E factor E, so 1 E will cancel it. And again, looking at this, root 3. So we have this time that 2 times 2 root 3 is 4 plus 2 root 3 is equal to E. So the side of this triangle, equilateral triangle, is E. Therefore, the area of any equilateral triangle is always root 3 over 4 E squared. E squared, which is root 3 over 4 plus 2 root 3 all squared. So as you can see, there is 2 here, there is 2. We can factor the 2, so 2 squared is 4. So I have root 3 over 4. 2 squared is 4 times, we are left with 2 plus root 3 all squared. So I have root 3 times, we expand this, root 3 squared is 3 plus 2 squared, 4, 3 plus 4 is 7, so 7 plus 4 root 3. And if you open up, therefore the area, which implies that the area of the triangle is now equal to root 3 times, that is 7 root 3. Root 3 times 4 root 3 is 12. So the answer is 7 root 3 plus 12, which is option A. So it's a very tricky question. So the main thing here is to relate the sides of the equilateral triangle, and the main thing is the relationship between the side of the square, the height, and the base of a triangle where the square is inscribed as shown. So that's the major thing here. So that's why, because assuming we don't know this formula, we need to solve to get something like this. Even this, so it's the same thing as the formal diagram, just we use the alphabet as letters to represent the sides. So we are going to use similar triangles. So let's get the height of this small triangle, because this is a square. Let's call the side of the square x. So here is x, here is also x. So we have two similar triangles. So if we join the heights, like we get the height, we see that from here to here is x, because it's a square, while here is now h minus x. So using similar triangle theorem, we have that h minus x over h, that's this one over the long one, h, will be equal to x over e. That's by similar triangle theorem. Because triangle E, that's because triangle EAB is similar to triangle EFG. That this small triangle is similar to the big one. So let's open up, let's simplify. This is 1 minus x over h. We have x over e. So our main aim is to get the side, which is x, in terms of h and e. Okay, so we collect like terms. We have, this goes over, so we have with 1 here. So x over e plus x over h. And if we factor x, we have 1 over e plus 1 over h. So which is, if you simplify this, we have EH, while here is E plus H, 1. So making x the subject of formula, therefore x is now EH over E plus H. So that's it. That's how we got the formula. That's the side. Once a square is inscribed in a triangle, you are given the height of the big triangle and the base. So it's just the product of the height and the base over their sum.